So we're the All Saints Solar Car team. We used PyTop in our race last year and ended up winning the electric division and got an award for it. And this is pretty much how we use it and the processes we used and problems we occurred while trying to use it.
Give us 1 second. Okay, good.
This is a laser.
Advancing? No?
So the whole entire reason why we're using our PyTop was as a telemetry system to help monitor not only the input from the solar panels in our trailer, but also to measure the output of the battery from our propulsion battery, the main battery. So what we were able to do with this was find the amount of current running through, find the most efficient current with how we were charging our battery, our extra battery, and then find the most reasonable using this. So this has many extra benefits that we haven't been able to use quite yet, but one extra benefit would actually be able to be used is a bad sensor monitor or a bad battery monitor. So if a battery is not working to the maximum efficiency, we would be able to tell by having like a Hall effect sensor on on each separate battery within our battery cage. So in order to hook up our Arduino to the solar car, what we used was our auxiliary battery, because what we found was it did not require that much battery input, so it didn't use too much energy for one, and then also if we wanted to connect it to our main battery, which was an option, we found that because the voltage was so high, we would have to use a resistor to help decrease that voltage to make it for the components. One extra option was actually using a third battery to help just solely power the Arduino by itself.
In order to find the current, you had to get a Hall effect sensor. And the reason you had to do that is because the Raspberry Pi with the PyTop would only read voltage. So we thought maybe we should get a shunt. And we did that and it worked, but it didn't pick up the smallest voltage and current readings. So we had to go to the Hall effect sensor with the converter. And the Hall effect sensor reads the magnetic field going through a wire that it's hooked around, and it gets like transferred to the converter, which converts it to the current. And they're hooked up. The Hall effect sensor can be on any wire. We put it on a 4-gauge wire, and 2 wires from the Hall effect sensor go to an ADC input, and 2 go to the converter.
So in order to get all the data across, because, I mean, we aren't going to be having the same Arduino monitoring the car, the charging station, and also the monitoring system, which is right here. We had 3 different boards, and each board had a specific process. And so we had one board on our solar car which measured the battery output using, like you said, the Hall sensor. But we also had one more car in our trailer where we were able to find out how much energy was going into our extra battery while we were driving. And so using that, we used we were planning on using an antenna actually, but what we found was the trailer blocked the range of the antenna, so we actually used a Wi-Fi extender or a router or something similar to that to get the data to our computer in the chase car. And so using that, we were able to compile all the data to one computer that we were able to view it on.
So with the Raspberry Pi and Arduino and coding, you can do a lot of stuff. And I'll talk about a couple that we were thinking about doing, like a current indicator to put on the dashboard of the car, where if you're going at a perfect speed and you're using the good amount of current, a blue light will come on for the driver to see, and you won't need to be told anything from anyone in the car who's reading it. And if you're going too slow and you're not getting enough out of the batteries, a green light comes on. And if you're going too fast and you're using way too much current, a red light will come on. Also, we thought about having a single battery system where we read the outlets in each battery, because like batteries come in a four pack of 4 different batteries, and we can read each one with coding. But we never figured that out, and if you wanted to do it, you would need a different thing than the Arduino because it didn't have enough ADC inputs. Also, Matthew and I worked on 2 projects this fall, including sensors that let us figure out how far away a car was, and it could beep or put a light on if anything was too close, so it could help us with parking in a trailer or seeing if someone's coming behind us. Where if we put a sensor pointed behind us and if they got a certain distance too close, a light would come on and beep and you would know. And another thing you could do was hook up the coding with the brakes and the speed. So if you can measure how long it takes to brake with the miles per hour you're going to see if your brakes are being faulty at that moment or not.
And as we get here, I would like to just let everyone know that our 2 members who actually wrote this code for our telemetry system have left. And so due to their documentation, which was actually very good, we were able to help understand what they wrote and present it today. So we were not actually the 2 members who helped create this, but we are heavily involved in coding with our team. So any questions?
Another thing before we do questions, y'all all should have got, are you passing them out? So everyone will get the packet we used to pretty much write this presentation explaining how we did it. What's your question?
How hard was it initially for you to work with the Raspberry Pi?
I mean, the first initial thing that we have to understand is this Python that we were using to write it with, but we actually had a sample code or something like something to start off of GitHub, thanks to Solar Car and the people at PyTop. And so if we actually ran into an issue doing this, which we definitely did, we actually had connections and people were more than glad to help. It's difficult, but you definitely can overcome those issues you come up with.
Also, when you're starting out, you get a PyTop and a starter's kit with lessons to teach you how to do simple stuff leading up to more complicated things that can help you in racing. Any more questions?
Are there any potential pitfalls you would suggest for beginners to avoid?
I mean, if you're programming something and you come into, if you hit an issue, some issues I think are definitely too advanced to overcome. I mean, I'm not saying that you shouldn't try, but you have to kind of think about options sometimes. So if try something and it doesn't work and you could spend technically multiple hours trying to figure that one thing out, there's probably like 10 other paths you can take to figure something out. So did that answer your question?
Also, last year I wasn't on the race, but I know whenever we did have a difficulty, like with the Hall effect sensor, we got Jarrett to help us, and he's a really nice guy, and he helped us out a lot.
Are you giving them $20 per person to say that?
Yeah, thank you for the kind words. But yes, there are people here, and this is an educational event, so the goal is to learn things. So there are people here to help. Contact information is available on the web, and we do answer questions. And you can also reach out to the other teams on our Facebook page and other places. So definitely reach out. And I agree with you that there are many ways to do things. So if you get stuck, the other option is reach out and ask for help. I've been doing this for 15, 20 years. I still have people I reach out to because I'm a mechanical engineer by trade. I'm not an electronics expert, so when I get stumped, I reach out for help.